All right, so we're going to go through numbers 21 through 30. So for 21 and 22, the direction is to solve the following absolute value equations. Okay, so here's how we approach that. This says that the absolute value of 5x minus 3 equals 17. We know that the absolute value is distance from 0. So this in here, this part in here, it needs to be 17 units from 0. So 5x minus 3 can be either 17 or negative 17. So that's why we set up two problems. We have to solve 5x minus 3 equals 17, or 5x minus 3 equals negative 17. Because, again, that inside there, 5x minus 3, is 17 units from 0. So when I solve these two, we use the reverse of the order of operations, right, SADMEF, to solve. So first we'll add 3 to both sides for this one. We get 5x equals 17 plus 3 makes 20. And then divide by 5. Opposite of multiply by 5 would be to divide by 5. We get x equals 4. And then over here, we do the same thing. Let's add 3 to both sides of the equation. That cancels out, makes 0. We get 5x equals negative 17, and positive 3 adds to negative 14. And then we can divide by 5, opposite of multiply by 5, and we get x equals negative 14 over 5. So you've got two answers there. You've got x equals 4, or x equals negative 14 over 5 will make this work. All right, so that's that one. 22. The first step here is we need to get the absolute value by itself first. So how do we do that? We've got this minus 3, so we'll add 3 to both sides to get the absolute value by itself. So we end up with the absolute value of x plus 2 equals 4 plus 3 is 7. So again, this means that in here, x plus 2 can be one of two things. It can be positive 7 or it can be negative 7, right? Because if negative 7 were in there, the absolute value of negative 7 equals 7. So we're going to set up two equations. This could be 7 or it could be negative 7. So the problems we set up are x plus 2 equals 7 or x plus 2 equals negative 7. In solving these two, it's a quick one-step equation. Subtract 2 from each side. We get x equals 7 minus 2 is 5, or we subtract 2 from both sides and we get negative 7 minus 2 is negative 9. So we get x can also equal negative 9. So those are the two possible solutions that make this absolute value equation work. All right, moving on. You've got some inequalities to solve. Solve the following inequalities. Remember, the process of solving an inequality is the same as the process for solving an equation, right? And we use SADMEF. That's the order that we get that variable by itself. So in this instance, we've got following the order is just we need to move this negative 3. So the opposite of subtracting 3 would be to add 3 to both sides. That makes 0. We get y by itself, which is less than negative 7 plus 3 is going to be negative 4. Y is less than negative 4, and that's fine just like that. 24 here looks a little bit different. The variable's on the right side. That's okay. We're going to do the same thing. It says x plus 8 right here. X plus 8. The opposite of adding 8 would be to subtract 8 from both sides of the equation. And remember, when I say both sides of the equation, I mean of that inequality sign. So positive 8, negative 8 makes 0. 12 minus 8 is 4. This inequality, we'll keep it the same for now. It says less than or equal to that x. What I like to do so that when we're graphing and stuff, put the variable first. So if we were to put the variable first here, x, it's open to the x, right? The inequality is open to the x. So if we were to rewrite that, it needs to be open to the x, and just like that. X is greater than or equal to 4. Number 25 here. 2/5 x is greater than or equal to -4. So it has a couple steps here. This is saying 2 divided by 5 times x is greater than or equal to -4. So 2 divided by 5, the opposite of dividing by 5 would be to multiply by 5. So that's our first step. We're going to multiply by 5 on both sides of the inequality. 5, that 5 over 5 is going to make 1. So we're left with 2x is greater than or equal to -20. All right, then we have one step here. 2 times x, the opposite of multiplying by 2 would be to divide by 2. So we get -20 divided by 2. It's negative divided by positive is a negative, so we get -10. X is greater than -10. All right. Number 26. This is a really quick one, but there's a really important step to remember. This is -2 times x. The opposite of multiplying by -2 would be to divide by -2. So if I divide by -2 on both sides of the inequality, that cancels out. That gives me x by itself. But remember, when we divide or we multiply by a negative number, we need to flip the sign. So this says greater than here. We need to flip the sign to less than, and we have the 16 divided by -2, -8. There's our answer. X is less than -8. So don't forget to flip the sign if you divide or multiply by a negative number. 27 here, we have variables on both sides. So first what we can do is, let's move the variables all to one side. So here it says -3x. The opposite of subtracting 3x would be to add 3x to both sides of the inequality. -3x, positive 3x makes 0. We have 1 is greater than. When we're adding that 3x, we're adding it to the 1x right there. So you have 1x and 3x adds up to 4x's in total, minus 11. So now here we've got this minus 11. The opposite of subtracting 11 would be to add 11, which, remember, we do to both sides of the inequality because it's like a scale. What you do to one side, you need to do to both sides. This here makes 0. So 11 plus 1 on this side makes 12. And then is greater than 4x. Last step, opposite of multiplying by that 4 times x is to divide. So we divide by 4 on both sides of the inequality. That will cancel out. 12 divided by 4 makes 3, which is greater than x. Remember, I like to put the variable first, so if we were to flip the direction of the inequality, it's pointing at the x, so it would be x is less than 3. Just like that. 28. We need to simplify the right side of the inequality first by distributing this 2. So when I distribute that 2, I get 2 times 3x makes 6x, and 2 times 1 makes positive 2. Over here we still have 6x minus 3. So for this one, let's simplify a little bit more and see what we can move around and what we end up with. So if let's say this is a positive 6x and this is a positive 6x. Either way, I can subtract 6x from both sides of the inequality. This will make 0, and this will make 0. So all my x's are gone. They canceled out. On the left, we're left with -3, which is less than. On the right, we're left with positive 2. Because this is a true statement, -3 is in fact less than or equal to 2. It's less than 2. This is true, which means that all real numbers will work in the spot of the variable here. So because it's a true statement, the answer is all real numbers. If it happens to work out and it were a false statement, a false inequality statement, it would be no solution. All right, we have a few compound inequalities here. This is just saying there's two different inequalities we're solving. We're solving negative 3 is less than or equal to 2x minus 17. And we're doing 2x minus 17 is less than 1. So what we can do is we're just going to solve those two at the same time. So what we do, say to the middle here, to get this 2x by itself, we would add 17. You're going to add 17 to each part of this compound inequality. So you've got three different parts here, right? You're going to add the 17 to the negative 3. You're going to add the 17 to this negative 17 to get rid of it, and you're going to add the 17 to the 1. 17 and negative 3 will add up to 14, less than or equal to 2x, which is less than 1 plus 17 makes 18. And then to get the x by itself here, we'll need to divide by 2. But you do that to each part of the compound inequality. So that'll cancel out to make 1. 14 divided by 2 is 7. So we get 7 on the left is less than or equal to, x is now by itself, which is less than 18 divided by 2 is 9. So there's our compound inequality. That's an and statement. Or statements would never look like this. If you had an or problem, like you have on number 30, you would never make it look like this. Okay, this is saying that your answer is essentially between 7 and 9. With on the 7 side, the circle would be bubbled in, and on the 9 side, it would be an open circle. Last one here that we'll go over. So this is just two different problems here. So if we solve this one first, x minus 2 is greater than 7. We would add 2 to both sides, giving us x is greater than 9 for that part. Or here we need to divide by negative 3 on both sides of the inequality. But when we divide by a negative number, as we already said, we need to flip the sign. So I would flip the sign instead greater than or equal to 15. So we're going to change it to less than or equal to. 15 divided by negative 3 is negative 5. And there's our compound inequality answer. Stop. Thank you.